I believe you can see my screen now. Yes? No, maybe? Should be. Can you see it?
Yes. Yes, I can see it.
Wonderful. Well, thank you very much for coming today to hear me talk about Databricks, which is obviously a very hot topic, which is why there's two sessions at the same time on it. Databricks is not a new product, and it is not a Microsoft product, which is kind of makes it an unusual Azure offering. I would like today to show you how you can use it, what it's good for. I talked to someone recently, and they wanted to know, why they should use it, because their manager wanted them to use everything in Azure because it's cool. While that's a laudable reason to use things in Azure, there are some reasons that you want to use Databricks, and there are ways that you can scale up into it and save money by starting your work locally if that works for you. A little bit about me. My name is Ginger Grant. I'm on Twitter at Desert Isle SQL, and I have a blog by the same name. I'm a bit of a writer. I wrote the exam ref book 7774, as well as keeping up with my blog. I am a Microsoft certified trainer, and I also have a course at Data Camp as well. And I am an Adira Ace, and recently was re-awarded a Microsoft MVP Data Professional designation for Data Platform. Okay, what is Databricks? So it is a Spark environment. Databricks is a product that was built on others. It is built on both the cloud and on a lot of Hadoop-based components. It's designed to be a single engine for processing, batch streaming, and machine learning. So it takes technologies from all three of those areas. And so it's not just one product, actually, it's a conglomeration of products. One of the things that Databricks brings to it is its ability to provide a space where users can not only work in their own environments, but share with others. And so it's designed to be a corporate environment, which incorporates source control and working with others. And it's extremely scalable. One of the big components of Databricks is your ability to attach as many threads to it as you need, so you can scale it up to nearly infinite scale. So a little bit about the history of Databricks. Earlier, I think it was 2004, there was a conflict that Netflix had to find out who could come up with an algorithm to find out who could pick the most appropriate movies based on your viewing selection. And there were a number of teams that tried it. The winner got $1 million, and then I believe he is now at Google. He started out at Facebook. But the engine that was used to create the second place winner, they didn't win, they came in second, for that contest was what became Apache Spark. And the idea with that underlying technology is to look at data that is stored in a Hadoop cluster and take that data and determine how to process it in the most efficient manner possible. And that's how Spark was created. So it's designed to do a lot of multi-processing of data, taking the same components and then applying it to multiple sets of data at the same time and then bringing it together at the end. The guys who wrote it were all based out of Berkeley, and they open sourced the Apache Spark product, and it became part of it in 2013. They built it using Scala. And 75% of the code, the guys who wrote that, they decided that they had some ideas for improving the product, adding new features and doing things that weren't in the original Apache Spark thing. I know this is no shock for anybody who's ever developed something, because after you think about it for a while, you can always think of a way you should have, could have done it better. And that's what they were looking to do. This time they decided that they would actually make money out of their endeavors. They didn't want to be starving graduate students forever. So they decided to create a product using this in-memory framework and build upon it so that it would have the other features that they had in mind. So they developed a cloud-only solution. The reason it's cloud-only is because it's designed to be able to access additional memory and cores whenever it needs it. And with that in mind, you could use it for cloud workspaces. And you would only need to allocate the resources when you needed it, and then you could spin it down. This product was originally created in AWS's cloud. So, like I said, it's not a Microsoft product, but it was licensed to Azure starting in March of 2018. I know that if you look at a lot of the Azure products, you may wonder, wonder how this fit into Microsoft's overall strategy, especially if you're looking at things like Data Lake Analytics and SQL. Well, to be honest with you, it's outside of Microsoft's strategy because it's a third-party product. So the components that you use with it are primarily open source, and they apply to both AWS and Azure. So if you learn Databricks and your company decides they want to change cloud providers, you can take the knowledge that you have gained using Azure Databricks and use it in AWS's Databricks, because the components contained within it are the same and controlled by Databricks, who creates documentation for it. So Databricks uses Spark, and what is Spark? Is that Spark allows you to read data simultaneously based on HDFS clusters. So the way that Spark works is it breaks up the data into little pieces, and it takes each piece of data and simultaneously applies code to processes it, and then brings the results back together. So it's reading the data and caching it in memory and processing it, and it does this very, very quickly, and scaling to how many data sources that it has available. It's designed to work extremely well. So you can use this for iterative processes. And by the way, this is the exact sort of thing that makes it really, really good for machine learning, is its ability to apply an algorithm to a set of data and then combine the results, which is really what you need to do when you're doing a lot of machine learning or streaming processes. So for machine learning, what you do is you take an algorithm and you apply it to a set of data to determine a set of results. There are a number of different languages that you can use to do this. Many different languages contain a lot of machine learning libraries that contain these algorithms so that you can apply them to the data. But one of the two languages that you see mostly are R and Python, which are the most common languages used if you are creating a machine learning solution. Generally speaking, with R, Python, you run things as batch. For example, if I want to do a batch process for machine learning, I might want to take all of my existing customers and then look to see which ones would be most likely to buy another set of products based on my data. That might be something that I might do as a batch process. A streaming process, which perhaps you've encountered, is if I've got a credit card transaction, what's the likelihood that that could be fraud? And so it's taking an individual transaction, running the algorithm against it, seeing how well it scores to see whether or not it's an anomaly record. Two different kinds of processing, but both of them you can do with Databricks. So machine learning has recently added a machine learning preview feature, and it is designed to assist in monitoring machine learning processes over time. This is really important because things tend to change over time. One example is definitely looking at anomaly detection, because crooks tend to change their patterns. For example, I worked for a very large credit card provider, and at one point in time, if you changed your address to Hollywood, Florida, they would probably stop your credit card and give you a call. And the reason why is there were so many fraud rings running out of Hollywood, Florida. Well, I am sure that the crooks who were stealing credit cards also figured out that if they have a Hollywood, Florida address, that their scams weren't working, so they probably moved as well. So little things like this cause your models to be ineffective over time. And what the machine learning monitoring process does is helps you look at reviewing and monitoring your machine learning processes over time. Currently, this only works with Python and Scala. They are planning on releasing a version in R before it goes from preview to load, but it's not there yet. So you can write it in Python or in Scala to monitor your Databricks machine learning processes. So you can create a analytic solution using a number of different tools. The most common ones that I use SQL and data visualization. And the reason that I use SQL is because I know it and I'm gotten rather good at it. SQL is very helpful because the biggest thing that you do with machine learning is, of course, analyze data and determine the quality and patterns within your data. And you can do that with SQL. You can write R code or Python code to analyze your data. But these are, I'm talking about pre-processing steps, not what you would use necessarily to write algorithms. Another common thing that you can do is data visualization to look to see what your range of values are. Do you have a normal distribution of data? Are you missing a number of data elements? This is the kind of thing that you can find very easily if you just look at it very quickly. Analytic solutions are written in a lot of different languages. Like I said, primarily Python and R. But Scala is, used a lot too, and which language that you use depends a lot on your environment. I've done a lot of work with insurance companies, and they are some of the early adopters of machine learning, and as a result, they've got a lot of existing R code and R expertise in their environments. As such, they tend to write a lot of analytic solutions using R. Other companies that have started later, perhaps have you started using Python because it tends to process more quickly. The libraries that support these are important, and also where you're going to be putting your data. So these are all common components and challenges that you have to analyze when you're looking at any machine learning or analytic solution. And Databricks is designed to handle all of these components because you can write SQL, it handles data visualization, it can handle multi-languages, it's got the ability for you to add any R or Python or Scala library that you so choose. You're not limited by what's loaded there. And you can use a number of different data storage components. You might want to use Blob Store. You might want to use an Azure SQL database. You might want to use an HDFS cluster. It doesn't really matter where you have your data stored. Generally, you can set up a tunnel for Databricks to access it. You can even load data if you like to a local server, but that's kind of a complex process, and you're probably, from a processing perspective, going to want to move it to a blob store for more efficient and cost-effective processing. But it's available for you to do should you wish to do it that way. So you can use, managed service data offering with Databricks. So Databricks is considered managed service because of how it manages it for you. It's integrating Active Directory security, so it uses that component. It has a group development environment, which again integrates with security, and the runtime is serverless. You do not have a whole lot of control over the versions that are running. You can pick the versions that you want, but the versions are managed for you. You don't have what you would have, say, in some Python environments where you've got different environments that you might run your Python code. You have one environment, and that is managed by Databricks, and they handle all of the I/O as well. So how would you run a Databricks process? Well, you can incorporate it as part of, say, an Azure Data Factory solution, or you can use it independently of ADF. What the Databricks will do as part of its processing scene is it will move your data wherever it is into its file structure, because that is how the underlying technology works. You need to be able to copy the data into Databricks, put it into a format that it can process it very rapidly, and then the data is moved out. So, because internally, what you're really doing is running a flavor of HDFS. You don't see that, you don't have control over that, but internally, that's really what's happening. It doesn't really have access to data in the Azure cloud. You can kind of make that happen with ADF, though. You can take data from wherever you want and send it to it. But that is really a processing step that you would need to initiate over and above what's handled within Databricks. And it's considered a very secure environment. Now, Azure Databricks uses Jupyter Notebooks as the place that you write all of your code. Jupyter Notebooks started as IPython notebooks. It includes both of your code and the data. I actually did a session on Jupyter Notebooks for the cloud chapter about a year ago. So if you're out searching on YouTube, you could probably find it to get more information about Jupyter Notebooks. But it's widely used in a number of existing environments and uses Markdown to format text. And it's the primary method for interfacing with code with Databricks. Obviously, it's gotten to be such a popular format. It is in Azure Data Studio, and it's considered another way you can access SQL data in SQL Server 2019. So the environment collaborative environment is included because, let's face it, most of the time you are accessing a project with groups of people. Multiple people need to access the same files or look at the results or see what's running, and you have that with Databricks. It integrates with GitHub so that you can contain versions of your code within Databricks. You don't have to set any of this up. This gets into the managed environment, and the team environment can be interactive as well. By default, what you do with Databricks is you create clusters, and these clusters will turn itself off in 2 hours. This can help you decrease your Azure spend. I can't be the only one who ever accidentally left something running over a weekend that generated a huge Azure bill. Fortunately, Databricks was written so that you won't do that. It is designed to auto scale based on the load, and when you load things up and run in Databricks, you don't have to have the cluster started first. It can auto start the cluster. There's a lot of different pricing components that are involved with this, so you want to look at Microsoft's pricing details, of course, for your source for this, because what I say now might be wrong tomorrow. But the crux of it is that you purchase various resources for Databricks. Of course, the faster, better, more you pick gives you faster, better pricing, increased pricing. So keep that in mind. Also, not all pricing options are available in every location. So it's really important for you to check out this first, especially if you're looking at doing something that is really memory intensive, because the option that you want may or may not be available in the data center that you are. So it's good to check this out first, because once you get to the point where you're able to choose it, if you pick the data center, then you're going to have to start all over again. So keep that in mind. For Databricks pricing, there are 2 major tiers, standard and premium, and 2 different workload options, data engineering and data analytics. The big one is data engineering does not include the interactive clusters, and the data analytics does. The standard operation does not include all of the workspace features. So if you are just trying this out, you might want to consider just creating a standard package, because that will, of course, decrease the amount of money that it costs you. But you also have the ability to create a free trial. So it's only lasts for 14 days. So make sure that when you start it, you have something to do for 14 days, so because then it'll go away. And that is a premium option as well. So you can take a look at the features when you create your own account. So the process for creating your own account is pretty simple. The first thing that you do is create a cluster. A cluster is the server resources that you use from within Databricks. This is where the machine that is running your code lives. Once you've got a place that you can run things, then you need to load a reference data source or access a reference data source. Naturally, you can access Azure Blob Storage, then you don't need to copy anything in. You do have the option of copying data in should you choose. Then you have notebooks that you can either upload or write that will allow you to run code against the data that you have uploaded. You can take a look at dashboards for performance, looking at the different data sets, looking at implementing runtime solution, and then you can schedule ongoing runs of the jobs. This is the process that you would use to create a Databricks process, which we are going to go ahead and do here just in a second. And basically, this is very similar to what you would do if you are writing a machine learning process. So you'd write some code. In the past, you would rewrite it in Java and then write a web service to our API to implement it, and then migrate code to use SQL Server to the web server. But we are going to forego all these processes, instead look at creating a Databricks solution instead. So let's go ahead and take a look at Azure and what you would need to do to create a resource for Databricks. It's relatively simple. I'm going to go ahead and create a Databricks resource. And I'm lazy, so I'm just going to look for Databricks. Oh, come on. Which is under Analytics, Databricks. Now, I'm not going to actually create this service here because it does take about 10-15 minutes. If I'm doing a demo, it would take 20 for sure to create this service. So I'm going to show you the steps that are required and then go to one that's already done. So you want to give yourself a name. Using the subscription of your choice. Resource group, I always create new ones. Location. Now this is where it matters what you pick based on the resources that you want to use, and you want to look this up in advance, because if I pick US2, which is certainly I'm able to do that, then I have different options that are available to me when it comes to processing. However, those processing options are not visible here. So you need to take a look at what processing options you're interested in prior to picking a location. And that information is not located here, so you're going to need to research it first. In the main, I'll tell you that unless you're looking for high-end data resources, you're fine with whatever ones you choose. But if you are looking for very intense workloads, you'll want to check that out, because again, that's when you get into availability based on location. Pricing tier, you have your free trial. The free trial can only be used once in the tenant, I believe. So I have already used this, so this is no longer available to me. Premium, showing you that it has more of your role-based access controls and standard. What the heck, we'll just say premium. And it's going to say, you know, do you want to deploy it in virtual network, which is a new preview option. Generally speaking, I don't use Databricks with virtual networks, so I always click that to say no. Now, if I said create and waited 20 minutes, then I would get, I'm going to go ahead and discard this. I would have this workspace. So let's take a look at the workspace that I have created in the past. So when you go into Databricks, you get this particular window. Doesn't show you a whole heck of a lot. It gets getting started guide, which is pretty useful. Tells you how to import data from files or from Azure storage, and a little bit more information about notebooks and admin guides. But what you really do within this environment is launch your workspace. And when I launch my workspace, it puts me into an entirely different window outside of Azure. Okay. And it's signing in using the information contained within the Azure tenant. So again, using Azure Active Directory is required as part of Databricks. So it's integrating the security within Azure into Databricks. And this is my window. I have a number of different options here on the left. I'm in on the Databricks screen. The home screen is shows you the number of users and the different files that I have loaded here. Workspace shows the users that I have available. Recent will show me this list here, the recent elements. Data. This shows data that I might have loaded into this or other data that I have accessed in the past. Cluster. I said the first step that you needed to do when you're getting started with Azure Databricks is to create a cluster. You'll notice here that I've got a number of different clusters. These job clusters were automatically created when my job ran. And when the job ran, it creates its own cluster and spins it up. So I don't have to do anything with these jobs. They just run by themselves. We'll take a look at one here. So it's just going to go ahead and run this automatically. If I went to this run, shows me what it's running. Go to the job run, it'll tell me how that it's doing slowly. And it showed me that it passed and it showed me what it ran. So I've got a sample job that's running. It does some linear regression with Python and it draws a picture. And I'm doing this on my data set, every night so that I can do some analysis of the data that may or may not be changing. So this is a separate cluster from a standard interactive cluster. Let's go ahead and create an interactive cluster so that you can take a look at how those work. This is, of course, the first thing that you're going to need to do after you create your Databricks instance. So I want to go ahead and start that now. By the way, that's not particularly clear in a lot of the documentation, so make sure you do this first. I'm again going to do what I call the Julia Child version of this, where I'm going to show you how it works and then show you what a cluster looks like, because I don't want to waste anybody's time in about 15 minutes that it takes to create this cluster. So we're going to go ahead and give it a new cluster. I have different modes. I can do standard or high concurrency. Of course, there is a cost difference between standard and high concurrency. If you are doing streaming, you're going to want a high concurrency. Generally speaking, for my purposes, standard is what I want to use. These are the different runtime versions of Databricks that you can use with the different options available to you. If you're looking for machine learning version, you will want to pick that. Otherwise, you might just want to go with the default. The Python version that you want to use, this was a great modification that they made, oh gosh, a couple months back, changing the Python version from Python 2 to Python 3, because like SQL Server 2008, Python 2 has reached end of life. It came out in version 3 came out in 2009, so it's been 10 years and it's has expired. So you're going to want to go with 3. Notice it doesn't ask you about R, but it does with Python. But you can use R with this cluster as well. It will allow you to enable auto scaling to increase the performance of your record over time. And this is where you get into the worker types. Now this list here, this is what varies based on your location that you pick. So remember when I said before that it matters which data source that you want? Well, I can tell you now that West US 2 does not contain these standard NC 12 beta GPU accelerated workers. You would need to look on the documentation to determine which one that you wanted to do. This does change. So, different items were available. I know that there was some compute optimized that were not available in this one that now are. So this is why your data, what you pick matters. So I'm going to go with a relatively inexpensive. This probably isn't great for processing in a corporate environment, but it is really more inexpensive if you were testing this on your own. So I wanted to definitely show you that. I'm going to get standard F4s. Now you have a minimum number of workers and a maximum number of workers, and these need to be double each other, and you have limits. Notice that it's based on my Azure account. So it's telling me that I don't have enough capability in my Azure account. This isn't Databricks, but in my Azure account, I don't have enough CPU cores available to me. So I would need to modify the type of Azure accounts that I have if I wanted to create Mint with this, because I already have other workers available to me. The smallest you can go is 1 and 2, because the max workers has to be greater than the minimum number of workers. And this is a good setup, again, for a testing environment. It is going to be relatively inexpensive. Again, if you are looking at speed and efficiency, you're probably going to want more workers than I have here. But if you're trying to minimize your Azure spend, these are the settings you're probably going to want to use. So if I went ahead and clicked on Create Cluster, in about 15 minutes, I would have this interactive cluster. One thing now notice this work cluster has gotten, I forgot to talk about this on the previous screen, the auto ability to terminate after 120 minutes of inactivity. So if this was turned off, I could change this. This is currently running. If this was turned off, I could change the minutes of inactivity to whatever I wanted. So I don't have to make it say 120 minutes. I can be cheap and say, after 30 minutes, if nothing's happening, turn it off. But by default, I get 20 minutes. And it will show me the notebooks, libraries, event logs, and that I have here. One thing that I wanted to tell you is that if you do not use your clusters periodically, they do go away, so that you no longer have things that are associated with them. So if you have been working on Databricks and you're like, oh, well, I'll just go back to my cluster that I've got, well, your cluster very well might not be there. So just keep that in mind when you're doing that. So once I've got this cluster created, I'm going to actually look at a Jupyter notebook that I have created that goes against a cluster. So pop into Jupyter Notebooks. I should actually have done this from the home screen, so I'm sorry about that. So what I wanted to look at is I want to look at my notebooks. And my notebook that I want to look at is airplane crash data. So I'm going to go ahead and click on that. And in this notebook, it's showing you the cluster that it is attached to. So every single notebook must be attached to the cluster because that's the machine that it is running on. So in this case, the machine is a cluster called Analysis. And you can see that it's got 16 gig, it's got 8 cores, and it's running Spark 2.41 and Scala 2.1. With this particular notebook, what I am going to do is I'm going to analyze some data that I uploaded about airplane crashes. Since I fly quite a bit, I have this morbid curiosity with crashes. This particular data set I have loaded in the data section. I did not have to, oh, that's interesting. I did not have to have it loaded here, but I did. And I could have accessed this straight from Azure, but I'm going to do a simple thing where I'm looking at Spark SQL. So I'm going to go ahead and run this. And you can see the different steps that it is going through to get the data using Hive. And it's going to go ahead and show the result here in a second. Now, this would have, of course, been faster if I had picked a faster cluster, but that's what you get for an expensive Azure. It doesn't perform as well as you like. What I probably need to do is go through and delete some of the clusters that I'm not using so that I can allocate more resources to myself. Come on. It still says it's performing catalog operation. Wow, this is really slow. I'm going to go ahead and not wait for this since I'm impatient that way, and take a look at showing you the data that was that I loaded into a data frame. I'm going to go ahead and show the result here. So this is the data that I loaded from my airplane crash CSV, and it's showing you the different data elements that contain with that data. So it's got the first column is date, and it has that as a string. And the reason that that date is set up as a string is because my data is dirty and has some stuff that is not recognized as date. Location, which is a string, an operator, plain type, how many people are dead, that has been defined as an integer, how many people are bored, and how many people are on the ground, and that was defined as an integer because I have bad data. So if you look here, I've got 5,643 rows and 7 columns. So let's go ahead and take a look at that data using the display of my data right there. And you can see that these are the distribution of the data that I have aboard. So this is not, this is again, one of the examples of the ability to visualize data. This has obviously gotten to be a really big thing because Microsoft has incorporated this same feature functionality within Azure Data Studio. And you can take a look at your data with Azure Data Studio using the same sorts of things that you do here. So I could change my view of my data to something like a scatter chart, take a look at the data that way so that you can see how my data looks at when you're looking at the number of dead and seeing how that looks at that way. So you've got a couple of different data options that are available to you to just take a look at your data to see how they're looking at. Once I've got my data loaded, I can use a Python magic command, and then I have the ability to look at my data here. And you can see here's the date, location. Again, this kind of acts like Excel. You can sort it this way as well. Operator, plain type, the number of dead, how many people were bored, and the number that were killed on the ground. So if you ran into somebody. So you can see here, note that I have a text field, NA, which is why this particular data element is text, not number. So I've got some numbers available in here. So this is just taking a look at my data and taking a look at what I've got going on so I can determine what I can possibly do with this. And I can even get clever and look at how many people showed up as dead. If I wanted to do that, I can look at loading the data into pandas, and then I can run the pandas command to just look at the first 5 records of the data, and then the last 5 as well. So just different ways that I have of looking at my data. And then I can be fancy and do some graphical analysis like I often do in Python, taking a look at using Seaborn. Note, I could just import Seaborn. I don't have to do PI. I don't have to import it automatically. All of the Anaconda libraries are loaded into this Jupyter Notebook, so you don't have to do anything special to get those to load. So if I run this, I can see a really nice graph of my data looking at the number of dead versus the number of aboard, just using some simple Seaborn, and then taking a look at my data here. And I can just look at my count of the number of dead, so seeing the different distributions. So a little bit of quick analysis that I can do with my data and taking a look at things within Jupyter Notebook and running this all in Python. Of course, if I'm going to schedule something, I don't, when I schedule in Jupyter Notebooks, it can be the same exact code. I have the ability to export this data. I can also look at importing different Jupyter Notebooks in the different section of the application so that I can start perhaps my analysis using on my computer until I run out of running out of resources, and then I could push my existing code to this environment so I have the ability to kind of like bounce into it, start locally, maybe do something cheap, and then load it up into Databricks once I have start looking at a lot of data. Okay, so with Databricks, you have the ability to create a lot of production-ready code, and implements R, Python, Scala, and SQL, and it can scale. You can use it with Azure Data Factory and store results in Azure databases. Where I put my results is completely up to me. Don't have to have them just visually showing up there. And you can automate the process with a Databricks job. So Databricks job is very similar to a SQL job. It allows you to run code inside your notebook on a schedule, and it uses existing clusters, or it'll create new clusters. What I showed you was the ability for it to create new clusters. When it does that, it just creates a cluster that it needs, spins it up, spins it down, and then stops running it. With Databricks jobs, you can have multiple owners for it, and notification emails are sent based on the statuses. You can send alerts for failures, configurable retries, and then define the scaling. So if you want to infinitely scale because you've got that kind of budget, or you know how much data you have, you can do that, or you can limit the amount of scaling that you are doing within Databricks. So Databricks also contains the ability to do structured streaming, and that's continually processing stream data. It integrates with Kafka, if you're familiar with that technology, which is also taken from open source. So with structured streaming, you have the ability to create a cluster which is on it all the time and is always processing data that you have streamed to it, and provides the interactive metrics as well. With Databricks, you can also do deep learning. One of the neatest applications that I saw that used Databricks and deep learning is a demonstration that Microsoft did on snow leopards, where they analyzed the video that they got to see whether or not there was a snow leopard in the frame or not. That particular technology used Databricks to able to handle all of the analysis that they were doing of the data. So Microsoft internally, of course, is using it for things to see how well they scale. So let's go ahead and take a look at jobs within Databricks. All right, so it's connecting now. I don't know why it's connecting. So I've got 2 jobs that I've created. One of them would be a notebook run, where it's running every month at the first of the month, and the last run succeeded. So let's take a look at this job. So you can see that this job has run successfully for a long time. Generally speaking, it runs about 4 minutes. There was some delay here. I started getting cheap, which is why I changed it to how frequently it runs. You can change the parameters as well, so that you can pass different parameters to it, so that it can run independently every evening. And you can take a look at the results for how this worked as well. So if I looked at my last run, I can look at again what it ran in my output, which is what we looked at previously. To create a new job, relatively simple. What I need to do is say create job, give it a name. It shows me how I wanted to, what I wanted to do with it. Generally speaking, it's going to load code that you have selected in a notebook. And you can go ahead and select one of the ones that you might have. So I'm going to select this one and say okay. You can edit your parameters. You can add dependent libraries should you need to, and then you can set up these schedules. So I'm going to go ahead and say edit, and this will show you when you can schedule it. So I'm going to schedule it every week, starting at 6 or 5 US Pacific, and say confirmed. And then if I go to advanced, I can get into my alerts. So I can alert on start, on success, or on failure. And I can don't have to send it if I skipped. So again, this is very similar from what you might see in any SQL Server job that you might be running. You have concurrent runs. You can run this at multiple times. So you can run the same job at the same time should you wish to do so. which you might do if you were running it with different parameters. Timeouts, if you want to kill the job after it's been running for a period that is too long, you have the ability to do that. Again, this is another great feature which will allow you to control your Azure costs, kind of a nice feature. Looking at timeout, oh, so I just did that. And then retries. So what you can do is basically see if it will restart the job after it has been unsuccessful. Generally speaking, is because the data might not be there, would be a common method that you would do this. Again, if you are running through ADF and that is where your data is coming from, you would use that to drive your data, not a Databricks job, but you do have the flexibility of doing everything within this environment instead of, you know, going back and forth between ADF if you don't wish to do so. One of the things that I wanted to make sure that I talked about here was the admin console. So you can see here, you can add any number of people that you have in your Azure tenant. So I can just go ahead and add anybody who belongs to the Azure Active Directory tenant. So you can't just add anybody, they need to belong to your tenant. You can create groups. These are based upon Active Directory groups, generally speaking. But you can add individual users to groups if you want to create separate groups within Azure, and then those people can be assigned different workspace storage. So you can you know, grant groups access to different items or grant users to access different items so that different people have the ability to access different data sources, etc. And you can look at creating workspaces and providing access to those workspaces to specific groups, clusters, tables. So by this way, you can control your environment and also work for others. Have that capability as well. Individual user things have different Git integration. So when you want to integrate your account with source control, this is where you would do that so that you can version the code that you write within Databricks. For notebook settings, you can have a couple of settings here that are overall to your settings that you have the ability to set as well. All right, so we looked at Databricks and saw about the features and functionality that it is able to do. Again, what it is an environment that you can use to write code that you have created within Databricks or perhaps created somewhere else. Allows you to analyze data and use that data in a processing perspective. It's very extensible. You can add a number of different libraries, use different languages. You can, of course, administer it and schedule it and use Azure Active Directory to contain information for a number of different users. Well, thank you very much for attending this presentation today, and I wanted to leave a little bit of time so that we could answer any questions that we might have at this point. Michael, do we have any?
Yes, we've actually got two. Okay, so Martin had a question. How much does this test specification cost to run?
If you are running, if you do the 14-day thing, that's free. When you are running Databricks, how much it costs you depends on what you're doing with it. There is a cost for having a Databricks cluster that's pretty nominal, like, I don't know, maybe $1 or $2 a month. However, how much you run and what you run has everything to do with how much it's going to cost you. And that's when you get into how many resources you've accessed to your cluster, how complex the jobs are to run. I can tell you that just running a job, I ran a job every day that wasn't that complex and did some other stuff to it, and that ended up costing me about $40 a month. So it really depends on what you're doing and how much you're running. And the more you run, the more it will cost, unfortunately.
Okay, well, that makes sense.
Yeah.
Then Tim would like to know, what is the use case for ADF codeless environments using Databricks for ETL?
I don't see Databricks necessarily as part of an ETL solution per se, but if you are running a ADF process where you are perhaps as analyzing the data or bringing the data from different data sources, and then once that data source is there, you want to run a nightly machine learning process on it. That's a great use case for incorporating Databricks into it. So if you want to, analyze your data that you get from multiple data sources and you're processing that in ADF, and you're like, oh, by the way, I want to do some analysis of, my customer base and see, which people are more likely to buy what products and run that nightly, I could do that off of an ADF process. So that would be a use case for that.
Cool. Okay, so Daniel would like to know, do you just depend on Databricks to split your queries up for maximum performance, or do you control how things are run?
You rely on Databricks to split it up for you. You don't really have control over the internals of the environment. So based on the number of the workers that you have set up determines how much it's breaking what up, as well as your configuration of the cluster. So you don't really control that once you've written that code. Good question.
Cool. In a similar vein, Ryan would like to know, should you run just one cluster when you are using the Python package like pandas? Or...
It depends on what all you're doing. You can create a very large cluster and it can handle pretty much anything you want to throw at it. If it depends on how many workers that you assign to it, which has a great deal to do with how efficient it is. So generally speaking, a cluster can handle all of your, work that you send to it, depending on the size of the cluster that you create. Because again,
cool.
that can scale.
Awesome. I think you sort of submitted a follow. Is that something that you can control, or does the Databricks just do that for you?
Well, again, this has to do with what you have set up too, because if you turn on auto scaling, which is on by default, then it will do it for you based on the parameters that you have provided for it. So you have control over how many resources it's going to use, by controlling the number of nodes. That's up to you. But if let's say that you're like, I've got 32 nodes, it may decide that that's not the most efficient way of doing it, and it may not use them all. It's internal to its environment, and that part's kind of black magic as to how many it chooses to use based on what you're doing.
Cool. All right. I think that's it for the questions. Ginger, we want to thank you once again for presenting to our user group. I hope everybody enjoyed it. There's going to be a short questionnaire just when you disconnect. Please take the time to fill that out. Provide both Ginger and ourselves some feedback as to what you enjoyed, what you didn't, and what you think can be improved. I don't have another talk scheduled just yet, but we will let you know when we have the next speaker available. Right, so thanks, Ginger.
Thank you very much, appreciate it.
We'll see you all again soon. Cheers.